Hey guys, today we are going to start chapter 4. So hopefully you grabbed notes in class or you printed some off. So chapter 4, we're going to talk about what are called polynomial functions. So this is an example right here of a polynomial function. It's, some number x to a power plus some number x to a, and then it's usually like 1 degree less than the previous one. This is a generic form of a polynomial function that's written in descending order, where whatever this exponent is, this is 1 less, and then 2 less, and then 3 less, until you get down to like an x to the first power, and then finally a constant. Any of these can be missing. You don't have to have a constant. You could have an x to the fourth, then your next one could be an x squared. You could be missing a term. But this is an example of a polynomial function. Where each of these numbers out front, so if you look down here, it says where these a's are real numbers, and n is a non-negative integer. So what does that mean? So these exponents have to be like whole numbers, but they could also be 0. Okay, so like this right here, this is technically an x to the 0 power. There is an x there, it's just to the 0, and so we don't see it. Okay. But all these exponents have to be like whole numbers. So like x to the first, to the fourth, to the fifth. You're not going to get an x to the negative 7th. You're not going to get an x to the 1/2 power. Okay, that would not be a polynomial. And then the degree, when we talk about the degree of a polynomial, we're just talking about what this biggest one is. Okay, so down here it says determine which of the following are polynomial functions and state the degree. So, well, I've got an x squared, an x, and technically an x to the 0 here. So that looks good. That is a polynomial. There's nothing making it not work. So yes, and it is a degree 2 because of the second power there. This is not. No. Okay, because of this fractional exponent or rational exponent. Okay. So you could just say exponent is a fraction or is not an integer. That's what the directions say, integers. There's no fractions. This one, also, no. We have a negative exponent. So that one is not a polynomial either. And then this last one, this is one that I put in here just to kind of get students to ask questions, but we can't really ask questions on here. So -5, just plain old -5. Okay, that is a polynomial. It's got one term. Think of it as an x to the 0 right there. We don't write that, but that's technically what it is. So yes, and it's degree 0. Okay, so so this next box right here, this is a summary of some of the polynomial functions you're familiar with. Degree 0, that's a constant. Okay, so just a number is a constant. The graph would be a horizontal line if you were to graph that, like y equals 3 or y equals 4 or whatever. Okay, a degree of 1, that means x to the first power. Now, this looks like it's written kind of confusing, like a1x plus a0. This is just slope-intercept form. mx plus b. They're just being consistent using the a's as the coefficients and the constants. Okay, so that's a linear function, and the graph of that would be a line. It can't be vertical, but it also is not going to be horizontal if it's to the first power like that. And then the last one that you are very familiar with would be a quadratic. Okay, a degree of 2 is a quadratic, and the graph of that looks like a parabola. And these are ones that you're familiar with. Later on, we're going to talk about x to the 3rd and x to the 4th. We'll talk about other powers, but we're going to start with what you're most familiar with. So the largest degree that you are familiar with as far as polynomials go would be a quadratic. So here's an example of a quadratic equation, and I want to solve this by factoring. Okay, so all right, so x and x, that goes first. And then factors of -3 that add up to -2 would be -3 and +1. Okay, so those are the factors. You know how to do that. And if these are the factors, then the numbers that would make either one of these 0 would be the solutions. So 3 and -1. Those are the solutions to this equation. Now, these are the two numbers that if you plug them back into the equation, you're going to get 0 as an answer. That's what we were trying to do. We were trying to figure out what numbers were going to give us 0. Well, when you're talking about functions, those have a special name. The numbers that we plug in to get an answer of 0 are called the zeros of the function. And if I take this function and I put a 3 into this function, so 3 squared minus 2 times 3 minus 3. If you plug that in and simplify, you're going to get 0 as an answer. If you take -1, now be very careful with the -1 squared minus 2 times -1. Make sure you square the -1 correctly. So -1 squared is +1. But then it's going to be -2 times -1, which is +2. So 1 plus 2 is 3, minus 3 is 0. Okay? So those two numbers are called the zeros of the function. If you're looking at a graph, these two numbers, or these solutions right here, are also your x-intercepts. So if I was going to graph this parabola, I know it goes through 3, it goes through -1. There's actually something else I know about it. I know the y-intercept. This number on the end, the constant, that's always your y-intercept. Just like it is with like a linear equation, same with every equation. That number on the end is your y-intercept. So, okay, so these 3 points, now obviously this is not a low point. The low point should be right in between these two. So this parabola would go down, and then it would keep going a little bit before it turned around and started to go up. Okay, so that's a quadratic. Now, what you need to understand, and this is hugely important, is that the solutions to the equation, the 3 and the -1, are the exact same as the zeros of the function, and they're the exact same as the x-intercepts of the graph. Those words are all interchangeable. Okay, so if you hear me say zeros, this is what I'm talking about. So if one of these makes more sense to you, then kind of latch onto that, but know that when I say the other words, that's just what I'm talking about. Okay? All right. Let's take a look at the back. All right. So identify the real zeros. So this little box right here is pretty much saying what I just said. If there is some number r, okay, it's a number, okay, for which when I plug r into my function, I get 0 as an answer, then these following 4 things are all interchangeable. First off, plugging an r into a function, getting a 0, means that r is a 0 of the polynomial, which also means that r is a solution to this equation right here. If I set the function equal to 0, that would be one of my solutions, r. r is also an x-intercept of the graph. And then also, if r is a 0, that means x minus r will be one of my factors. Okay, so if the number 2 is a 0, that means x minus 2 is a factor. If -3 is a 0, that means x plus 3 is one of my factors. Okay, if I know the factors, I know these 3 things, and if I know either one of these, I also know the factor. Okay, so like example A, find the x-intercepts for the polynomial. Well, this is in factored form. The x-intercepts are just the numbers that make these 0, which would be 1, 2, and -1. That's it. Understanding that if you have the factors, then you know the zeros, or you know the x-intercepts. I know this graph hits the x-axis at 1, 2, and -1. That's going to be important later on. Okay? For this one, x cubed, okay, that's a 0. If you plug 0 in for x, it's going to wipe everything out. So 0, 3, and -2. Those are my zeros of that one, which are also my x-intercepts. Okay? The next one goes backwards. It says, okay, given a polynomial with these zeros, what does the polynomial look like? Well, if I know these are my zeros, then I know this function has the factors x plus 4, x plus 2, and x minus 3. Those are the factors of that polynomial. So you could multiply all this out. So you could FOIL these two together. I'm going to x squared, and then it's going to be x times 2. So I'm going to get a 2x and a 4x, so that's a 6x. And then plus 8. And then that has to get multiplied by the x minus 3 there. Okay, so again, you would FOIL that out. Now, I've got the answer. I'm going to save myself a little bit of time here on this one. Okay, but again, you would take x squared times x and x squared times minus 3. And then you would take 6x times x and 6x times minus 3. And then you'd combine all those together, and you would end up with x cubed plus 3x squared minus 10x minus 24. And that is the polynomial that has those zeros. And if you test them, if you plug like a 3 in, 3 cubed is 27, 9 times 3, that's another 27, minus 30, and then minus 24. If you simplify that, when you plug a 3 in, you're going to get 0 as an answer. I promise. Okay? Now, looking at the graph of a polynomial, eventually we're going to graph polynomials. Now, here's some properties that polynomials have. First off, a polynomial function is always smooth and continuous. So smooth, we mean there's these nice rounded corners. There's these little areas where it changes direction, but there's no sharp points. Like this is a corner where the graph goes up and makes like a right angle almost. That would not be a polynomial. Or it creates this little cusp right here. So it curls up and then it curls right back down and makes this sharp point. That's not a polynomial either. So that's what we mean by smooth. Continuous means there's no gaps in it. So if you have a place in a graph where you have to stop, pick up your pencil, and then continue, or you simply have just a hole in the middle of your graph, that's not going to be a polynomial. Okay, so this is an example of a polynomial function. It is smooth and continuous. Okay? All right. Now, if you look at this one, this polynomial function, the ends of it go up and up on the ends. And there's pretty much 4 things that can happen. They can go up and up. They could go down and down. They could go like up towards infinity in one direction and towards negative infinity in the other, or that could get switched. Well, there's something about the polynomial that tells you what's going to happen. So if you are given some polynomial, so here's some crazy polynomial, all you do is you look at this first term right here. That first term is going to tell you exactly what the ends of your graph are going to do. And actually, more specifically, you're just going to look at this exponent right here. Well, the exponent, and then there's one other. All right, so first off, if the ends of your graph are going up and up, so think about a graph that you know where the ends go up and up. Okay, are you thinking of a parabola? You should be. Okay, so a parabola, you got this U shape, and then the ends go up and up. And actually, which is like an even, so x squared. And actually what we find is x to any even power. So if that is a 4, or a 6, or a 22, the ends of the graph will go up and up. Well, what would make the ends of the graph get flipped? Well, if you have a negative x to an even power, that's going to make your graph flip and go upside down. Okay? Look at this one. Look at how the graph's going up this direction, and then it's going down to negative infinity here. There's a parent graph in our library of functions that does that. Okay? X cubed. If you think of x cubed, that S-curve shape. X to an odd power. Any odd power will have that shape to it. Okay? And for it to get flipped, it'd be negative x to the odd power. Okay? So that's just looking at this front term, that can tell us exactly what the ends of the graph. So we got the ends of the graph, and we've also got our x-intercepts. We know those as well. So let's take a look at the last page. All right, so let's take a look at this last page. So at the very top, there's something else we can tell about the graph of a polynomial just by looking at the polynomial itself. And that's the expected number of times your polynomial is going to turn and change direction. Okay, and that again has to do with looking at the degree of the polynomial. But for this, it's actually one less than what that degree is. So if you have an x to the 4th power, you can expect that that polynomial is going to change direction 3 times. That's all that says. Just one less than whatever your degree is. So if you look at this like example of this graph right here that I have, this kind of a generic polynomial, it turns once, twice, 3, 4 times. So this is probably the graph of an x to the 5th power is what that polynomial would be. So since it turns 4 times, that means it's going to be a degree of 5, since the turning point should be 1 less. Okay? Now, we know we've talked about the fact that the factors of a polynomial tell you where the graph is going to cross the x-intercept. These are your x-intercepts. So this graph would cross at A, B, C, etc., whatever. But there's something else that the factors can tell you, and that's what happens at the x-intercepts. Because there's 2 things that can happen. An intercept just means you are making contact with the x-axis. Intercept doesn't mean you have to cross it and pass through. Okay, this is an example of an x-intercept where you're going up, 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 hit it, and then you pass through to the other side. Okay, so the graph can cross at an x-intercept, but if you look right here, this is still an x-intercept. The graph goes up, it touches the x-axis, but then it turns around and goes back the way it came. Okay, so there's 2 things that can happen at an x-intercept. The graph can cross, or it could also touch and then turn around and not pass through to the other side. Okay, so what is it that's causing that to happen? Well, it's something that's called multiplicity. So if a factor is repeated, we say that it has multiplicity. So this right here, let's say this is x equals 2. This x equals 2 factor, so x minus 2 would be the factor, is squared. That's what's going on here. Okay? Most of the time you're going to have like an x that that factor is going to appear once. So you'll have like x minus 1, just x minus 1. There won't be an exponent there. Okay? But this exponent, if it's whether it's odd or whether it's even, that's going to tell you what happens at the x-intercept. So if r is a 0 with even multiplicity, so this m right here is a even number, squared to the 4th power, whatever, then what's going to happen is the graph is going to come up, it's going to touch at that x-intercept, and it's going to turn around and go the way it came. Okay, so an example of this, think of x squared. If you have x squared equals 0, you have 1, 0, 0. That's the only thing that'll make this 0, but it appears twice. You have 2 zeros, actually. Your graph comes down, hits the x-axis, but then it turns around and goes back the way it came. Okay, that's an example of a 0 with even multiplicity touching the x-axis and not passing through. If you have an odd multiplicity, so think x cubed. Okay, what does x cubed do? It goes up, it goes through the origin, and it goes through. It passes through to the other side and goes that way. So if you have a factor that has an odd multiplicity, then it's going to touch. So these 3 points up here, those are zeros that have an odd multiplicity. Most likely they're to the 1st power, so it doesn't look like there's an exponent there, but it could be like a 3rd power as well. So look at this example right here. So I've got x cubed, x minus 3 squared, and x plus 2. So for each x-intercept, determine whether it is odd or even multiplicity, and then explain what would happen at that x-intercept. Well, my x-intercepts, I've got 3 of them. I've got 0, I've got 3, I'm going to list them vertically, and then I've got a negative 2. And the reason I'm listing them vertically is because I have some other things to answer. So 0, that is an odd multiplicity. It's x cubed. So that is odd multiplicity. And that means that at 0, which in this case would be the origin, the graph is going to cross. Okay, so it'll cross and go through to the other side. 3, that's an even multiplicity. And an even multiplicity means my graph will touch at that x-intercept. Okay? And then -2, don't see an exponent. That's because it's to the first power, and we don't write first power exponents. Okay? So that is an odd multiplicity. So again, that means our graph would cross at -2 and not touch and turn around. Okay? So look at these on the bottom. We are going to make some sketches of what we think these polynomials are going to look like. So we're going to take a look at the real zeros, so the factors. We're going to look at their multiplicity, so we know whether the graph should cross through or whether it's going to touch and turn around. We're going to determine if the graph, oh, that's what I just said. We're going to locate the y-intercept. I'll show you how to do that real quick. We're going to determine the end behavior, and we're also going to determine the maximum number of turning points. So there's a lot of things we've talked about in these notes, and we're going to put them all together right now. So first off, to determine the end behavior, we need to know what the overall degree of this polynomial is. Well, this is an x plus 2 cubed. If you were to multiply this out, and I'm not telling you to multiply this out, but if you were, the leading x term would be x cubed. That would be the degree of this, x cubed. If you were to multiply this all out, the leading term would be x to the 4th. But then those would end up getting multiplied together as well, so you would end up with an x to the 7th. If I were to multiply that all out, I would have an x to the 7th plus whatever, okay? But that's what I need to know, that x to the 7th. That tells me that the ends of this graph are going to go that way and that way. Okay, odd power, it's a positive x to an odd power, so that's the way the ends of my graph are going to go. I also know that the maximum number of turning points would be 6. Now, this isn't extremely important because once you start getting things like multiplicity and things, you probably won't even have 6. You could have 4, you could have 2, technically I guess you could have 0 turning points, okay, but it'll reduce in like factors of 2, but that's the most you can have. But you won't hear me talk about that a whole lot because it's not an exact science. That's just the most it could have. All right, so what else do we have? We know some intercepts. Our x-intercepts would be -2. Notice that is an odd multiplicity, so we know we're gonna cross. We also know +1 is an x-intercept. That's an even multiplicity, so we know it's going to touch. What about a y-intercept? Now, these are a little trickier to find. Now, just like I said, if I were to multiply this all out, I told you what that first power, that x to the 7th would be. Well, our y-intercept is what you get if you plug 0 into the function. It's what would happen if all the x's canceled out. Well, if you put a 0 right there, you're just going to get 2 cubed, which is 8. If you put a 0 right there, you're going to get -1 to the 4th, which is just 1, +1. So this is literally 8 times 1, which is 8. So that's our y-intercept. Okay, so here's what I know about this graph. I know the y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. I know there are 2 x-intercepts, -2, +1. I know the graph should go down to -infinity in that direction, and then it's going to go up to like +infinity from that x-axis. It has to go this direction. It can't like turn and go back down because there's no x-intercepts here. So the lack of x-intercepts tell you that it's not going to turn again. It's going to head towards infinity. What did we say our graph should do? At -2, the graph should cross the x-axis, so it's going to cross through, which makes sense because we want to head towards that y-intercept. So it's going to go up. Then it's going to turn around, head back towards this x-intercept. And again, what should the graph do? It should touch. So we should not pass through to the other side. We should just come down, touch, and then turn back around. And that is an example of what this could look like. Okay? This is just a sketch. This is not an exact science, just a sketch. Okay? B. Why don't you see what you can do with B? So again, figure out the overall degree of what this thing would be, x to the what power, because that's going to tell you what the ends should do. You could figure out what's the maximum. Notice this did not turn 6 times. It only turned twice. Okay, figure out your x-intercepts. And then what it's going to do with those x-intercepts, cross or touch. Figure out your y-intercept. Your y-intercept, if you just plug 0 in for your x's, you can simplify and figure out where your y-intercept is. And then make a little sketch down here of what the graph of this polynomial would look like. Okay, so I'm going to pause this. Why don't you pause this as well and try this out. All right, so first off, if you were to multiply all this out, this is an x cubed, that's an x being squared, and that's an x to the first power. So if you add up all those exponents, you're going to get x to the 6. Now notice that this leading term was a negative. That's a negative. So our leading term would be negative x to the 6. So x to the 6, that's even. So the ends would go up and up. They go in the same direction. But the negative is going to flip it. So the ends of my graph are going to go down and down. So hopefully you didn't get tricked by that. Okay, and if you did, you won't get tricked next time. All right, x-intercepts, 0, 3, and negative 2. 0 is an odd multiplicity, so it's going to cross. 3 is an even multiplicity, so the graph will touch at 3 and then turn around and go back the way it came. And then negative 2 is also one of my zeros, and again, that's to the first power, so that's an odd multiplicity, so the graph is going to cross there. If you plug zeros in for your x's to figure out where your y-intercept is, you're going to get 0, because this being a 0 just wipes everything else out. Okay? So here's what I got. So I labeled my intercepts. So here's the negative 2, the 0, and the 3. I also know what the ends of my graph are going to do. They're going to go down and down. Now I just got to figure out what's going on here in the middle. So at negative 2, my graph is supposed to cross. So I'm going to cross through to the other side. And then I'm supposed to go to 0. So that's my next x-intercept. So this graph is going to have to turn. It's going to hit 0, and it's going to cross again. So it's going to pass through. But then I've got this other x-intercept I'm supposed to hit. So again, my graph is going to have to turn at some point. Head back up here. And then at 3, I'm supposed to touch, turn around, and go back the way I came. So that is the graph of the function that I gave you. Okay? All right, so take a look at your worksheet. Try some of these on your own, and we'll talk about them next time I see you.